Yeah,
Are you recording?
recording is on.
Oh, okay, thank you.
255.255.0.
Very good.
10.1.1.1. Right?
Right.
Okay. And now I'm gonna go out from this one. Now I go here. 192.168.1.2. Okay.
Yes.
And 192.168.1.1.
Yes.
Now I'm gonna ping. Ping 192.168.1.2.
No.
Yeah.
Yeah,
Ping will
Oh,
work.
okay. Got it.
yeah.
Got it. Got it. Got it.
See, ping is working.
So yeah, that was my problem. Yeah, I got it. Now I
No,
understand.
no. This say like a 4 send and 3 received. I think you had some still have missed it.
No, no.
What?
First packet will, first time PCs need to resolve the MAC address. That's why first packet is dropped. If you will ping second time, all packet will be successful. Ping again. See, first time why one packet is dropped, request timeout. Anyone can explain why first
Yeah,
packet is dropped over here?
yeah. Because first time they will ask for the second PC MAC address.
Yes, exactly.
That's why they drop it.
Exactly.
Okay. So that was my question. Yeah, it's correct now. So I can use here like in IP, right? Like for different network.
Exactly. So
Okay, I
always
understand.
keep in mind that router connect different network. So on each interface of router, network ID should be different.
Okay, okay. So this network should be like different from this network. It shouldn't be in the same range, right?
Right.
Okay. Thank you, sir.
Okay. Now you can stop your screen
Okay.
sharing. Yeah. Let me share my screen. Let's say we have two computer 1 and computer 2. Suppose this computer MAC address is A and this computer MAC address is, let's say, B. IP address of this computer is, let's say, 10.1.1 and IP address of this computer is, let's say, 10.1.1.2. First of all, both machine need their MAC address, their destination MAC address to communicate. For that, both machine maintain what? ARP table, ARP table. PC1 also and PC2 also is going to maintain ARP table. This is ARP table of PC1 and this is ARP table of PC2. Inside the ARP table, there will be only one entry by default, IP address 10.1.1 and whose MAC address is A. Right? Inside this MAC address table of computer 2, there will be one entry 10.1.1.2 and MAC address is B. Right? So when we will ping 10.1.1.2, first of all this PC is going to check their ARP table, that in ARP table is MAC address available of 10.1.1.2 or not. So MAC address is not available. First of all it will resolve MAC address. First of all it will resolve MAC address by generating ARP request. Computer 1 will send one ARP request to computer B. ARP request. What is the use of ARP protocol? ARP protocol is used to find MAC address from IP address. So actually this ARP request, who is sending? PC1 to find the MAC address of router 2. It is asking that who is 10.1.1.2 till to 10.1.1.1 like this. After receiving this ARP request, PC2 will generate what? ARP reply. Inside the ARP reply, it will share their MAC address. And once PC1 will receive ARP reply, it will make one more entry in their ARP table, that IP address 10.1.1.2 whose MAC address is nothing but B, like this. Okay. In the same way, when PC2 will receive ARP request, it will learn the MAC address of computer 1 10.1.1.1 whose MAC address is A. Now you can see ARP table of both PC is updated. It can directly send ICMP request. Okay guys.
Yeah, clear.
Okay.
Yes.
This is how two machines communicate with each other. But this is how when destination belongs to same network. This time you can see destination belongs to same network. But in case my topology is not like this, my topology is like this. We have one router over here. And here we have one computer. And here I have one computer. So this time destination machine belongs to different network. Let's say MAC address of this computer is again A, MAC address of this computer is B. MAC address of this interface is, let's say, C, and MAC address of this interface is, let's say, D. Getting my point? This is your router R1. Done. So this time in ARP table, both machine is going to maintain ARP table. ARP table. This is ARP table of PC2. This is ARP table of PC1. Here let's say IP address of this machine is 10.1.1.1, and here IP address of this machine is, let's say, 20.1.1.1. Here IP address is, let's say, 10.1.1.100 from the same subnet. Yes or no?
Yes.
And here let's say IP address is 20.1.1.100. So if we will ping again, ping 20.1.1.1, right? Again PC1 need MAC address, yes or no? But this
Yes.
time it is not going to find the MAC address of destination device, because destination belongs to different subnet. Once we will ping to this IP address, first of all machine will identify that destination belongs to my network or different network. So you tell me, destination belongs to my network or different network?
Different network.
Different network, because network ID of destination is 20.1.1.0. Yes or no?
Yes.
And network ID of mine is 10.1.1.0. So both network ID is different. Yes or no?
Yes.
That means destination belongs to different network. So it will generate ARP for default gateway. ARP request for default gateway. For default gateway. And in their ARP table there will be two entry. 10.1.1.1 MAC address is A, and 10.1.1.100 MAC address is C. Getting my point, guys? in the same way, in the ARP table of PC2, there will be two entries, 20.1.1.1. MAC address is B and 20.1.1.100. MAC address is D, like this. Done. So when destination belongs to different network, then destination MAC address will be the MAC address of default gateway. So when this PC will ping to 10.1.1.2, source IP address will be what? Source IP? Source IP address will be the IP address of PC1, 10.1.1.1. Destination IP address will be IP address of PC2, 20.1.1.1. Source MAC will be what? MAC address of PC1, that is 0, sorry, A, and destination MAC will be
B,
not MAC address of
that
PC2,
makes B.
MAC address of default gateway.
Yes.
Yes or no? See,
Yes.
understand, router never forward broadcast traffic. Your ARP is an broadcast traffic. So PC1 cannot resolve MAC address of PC2 directly. So that's why whenever destination is in different network, destination MAC address will be the MAC address of default gateway always. Always keep in mind this thing. Okay. If you want to verify, how you can verify it? We can open GNS3. Here I am going to use one router and then let's say two PC. Done, guys. Let me show you the MAC address of all interface first. Here I am going to use IP address. Let me take access of all device first. If you want to capture the traffic, you can download one more software, that is Wireshark. Very simple to download. You can download the software and you can install it in your laptop. Wireshark
Yeah, I have it.
download. Like this, you can download this software and you can install in your computer to capture the link. Done. Now, let's say I am going to use IP over here is 10.1.1.1. IP over here is 10.1.1. Let's say 100. Done. Here IP address I am going to use is, let's say 20.1.1.100, and here I am going to use IP 20.1.1.1. Done. What I am going to do, show you first, I am going to show you the MAC address of all devices first. So to VPC, To PC1, I am going to configure one IP address, that is 10.1.1.1/24, and gateway IP address will be what? What is the gateway IP address of PC1?
10.1.1.100.
100. Very good. And so, see, this is the IP address of this PC. This is the gateway, and this one is the MAC address. Yes or no? Let me
Yes.
copy the MAC address, and I am going to paste this MAC address over here. This is the MAC address of PC1. In the same way, let me show you the MAC address of PC2. IP 20.1.1.1/24, and gateway is 20.1.1.100. Simply you can run command show to check the IP configuration. This is the MAC address. Let me copy it and let me paste it over here. See, this is the MAC address of VPC2. Let me show you the MAC address of router interface as well. Before that, I am going to configure the IP address. Interface F0/0 no shut, and the IP address is 10.1.1.100 255.255.255.0. Exit interface F1/0 no shut, and IP address is 20.1.1.100 255.255.255.0. Now, can anyone tell me what is the command to verify the IP configuration over here?
To check.
Yes, to check IP address.
that. Show.
So,
IP
IP
brief
interface
brief / all.
Like this also we can check, but here we have lots of interfaces. So just I want to check only those interfaces which have configured IP address. So what we can do, we can tell to router that exclude all unassigned interface. Exclude unassigned. So it is showing me only assigned interface.
Oh, okay. We can always use a shift and question mark, right?
Yes.
The brief just use and use.